Okay, this is a video that will document the results of finite element calculation of of a wave packet's propagation in a parabolic potential. The potential is shown by this green line here. Look at the mouse cursor, and the total energy, the starting energy of this wave packet, is shown by the red line. Now what will happen is that the packet will propagate over to this intersection between the red and the green lines, and then reverse direction and propagate back, and it'll go through a full cycle doing this. So I'll go ahead and start the movie, and you can see how it propagates. What is special about this one is the ratio of the width of the packet is from there to there is 2/10 of the distance from the center of the parabola to the intersection point, which is I should call X max. So now I'm going to start the movie, and we'll see what happens. So it's going over there, and if you'll notice with an R of 0.2, that it gets narrower and narrower as it approaches the intersection where it's going to turn around. That's quite different from the case we'll see next, which is with ratio of 0.04, and see how narrow it is. And gets really, the amplitude gets very, very large, turns around and comes back to the starting point, and it's completely periodic in its behavior. So it will now, when it gets back to the starting point, it'll look exactly the same as it did when it started. And then we're going to go another half cycle. At this point we have completed a half cycle, and we're going to go another half cycle and turn around and come back. So this is the case for a fairly wide starting Gaussian wave packet. The next thing we'll see is for a much narrower Gaussian wave packet, starting Gaussian wave packet, and it'll have quite different behavior as it propagates to the turning points, I should say. So we're just about finished with the wide packet, and when it gets back, the next feature will be the narrow packet, which will go through the same type of propagation. So here it is, just about, the center's just about back to the starting point, and now we have the narrow packet doing the same thing, going over to the turnaround point, but it's getting wider and wider and wider as it goes over there. In fact, now it's wider than the wide packet was at its start, and the number of cycles that you see is greatly reduced because its energy is lost. Its kinetic energy is reduced. Coming back, it's going back to the center, and it'll get very, very narrow, and the amplitude will greatly increase when it gets back, and it'll go back to its full amplitude, basically. So that's the behavior. So there are two distinct behaviors, one for a wide initial Gaussian wave packet, and a totally different behavior for a narrow initial width Gaussian wave packet. So this is about to turn around and come back to its starting point. And you notice that we get down to essentially 0 waves before it turns around, and very wide packet. So This is the first time that I know of that this solution has ever been shown, or publicized. So we're coming back to the center. Its amplitude will greatly increase, and it'll stop. So that was it for that.